So, my dear students, now we are going to look at lecture 12. In lecture 12 of module 4, we are looking for grade 2 XS3 code converter. So, the given input is gray, the output will be the XS3. So, first your objective is to design grade 2 XS3. So, first step of this process of building the converter or designing the converter requires truth table development. Then we will write the expression for output, of course, repeated steps that we are doing so far for various code converters. So we will derive the simplified expression using K-maps. We will get the logic expressions from K-map. From those logical expressions, we can derive the circuit diagram. So input is gray code, output XS3 code. Gray code is written 4-bit gray code, 4 zeros to, of course, 1 followed by 3 zeros, which is a pattern which follows. So whenever the input is gray code, it is not a sequential code. Like in binary code, you will get 0, 1, 2, 3. So you won't get that sequence. So you should take care of, you should track the sequence, because when you want to write the expression for output in terms of input, the input sequence is not in sequence. I mean to say, it is a arbitrary, like it is a sequence which is maintaining unit distance code, which is a gray code. So we need to we need to take care of that. So in the subsequent slides, I am going to show you how exactly we are taking care of that and trying to write the expression for output in terms of input. In XS3 code, it starts with the 3 and ends with the 12. Anything beyond that, which is greater than 12, is invalid. So what we try to do is, we do consider it as don't cares. So invalid outputs. So for those invalid outputs, what exactly that we try to do is, we will consider them as don't cares in the K-map to simplify the expressions. Now step 1 is done as a truth table. Now we are looking at the input output relations. So if you look at the output here, you can see here, so it is 1 for 7, 5, 4, okay, then 12, 13, and rest of them is don't cares. So the don't care terms are 8, 9, 10, 12. This is, 8, 9, 10, 11, then 14, 15 and 14. So this is 15, whereas this is 14. So 15, 14 we have written. Then if you look at the ones, it is 1 for 5, it is 1 for 4. So 4, 5, it is 1 for 7, of course. Then it is 1 for 12 and 13. 1 for 12 and 13. So what we try to do is, we will combine the terms. So one such possibility of combining is this one and this 4. Okay. So this 4 you can combine here, and similarly you can combine this 4. So we'll write expression for each and everything. So for this 8 ones, what exactly the expression look like? This 8 ones is x, right? And then this 4 combination turns out to be y, y and z bar, y and z bar, and this 4, of course, combination turns out to be y t. Okay, y t, because here t is changing, so z 0, z is 0, z bar. Here it is y and it is 1. This is t is constant, whereas z is changing, so we lose z, so it is yt. So is it not the expression for a is x plus y z bar plus yt? Yes, of course. So we will look for next output. Okay. So in step 2, generally we write expressions, but as we are so much familiar of this conversion process, so we know the don't care terms by default they are 8, 9, okay, 10, 11, then 15, 14. Then we will be looking for which it is 1. It is 1 for 1, 1 for 1, 1 for 3, 1 for 2, 1 for 6. So 1, 2, 3, 1, 1, 2, 3, 1, then 6, 1. So where is the 6 1? So where is the 6 value? 4, 5, 6. This is 6. So anything more? Yes. So total number of ones are for B is 4 plus 1, 5 ones. So 4 ones have taken. One more 1 is 13 is 1. So where is 13? 12, 13. 13 is 1. So now what I can do? I can do something like this. I can this combine like this. Then I can combine. I can combine. Um, I can combine like this. Okay. Then I can combine this 2 with this 2. So for this I can write expression. For this I can write expression. For this I can write expression. Right. But for this, what is expression? X Z T bar. For this, what is the expression here? It is T. It is T, of course, and here it is Y bar T. So it is Y bar T. Okay. For this two, if we want to write the expression here, okay. So this is X and this is T. So it is not XT, SXT. Is it XT? Yes. So it is Y bar, of course Y bar T, it is XT. So on the whole, so the overall expression for B will be it is XT plus Y bar T plus Z T bar. This is what exactly the output for B. So similarly, I can write the expression for C. So what I am trying to do is I am trying to enter the values of C. So C is equals to for 0 it is 1. Of course, we know that this is a don't care, this is don't care, this is don't care, this is don't care, this is don't care, and this is don't care. Now you enter the values of C into the map. It is 1 for 2 and it is also for 6. This is 6. Then it is 1 for 4 and 12. So this is 4 and this is 12. So what I can do is I can combine this 4 with this 4, which turns out to be C equal to T bar, because here it is changing completely, x and y changing, no xy will come into the picture. In this two if I compare, in this two if I compare, so here it is 1, here it is 0, so z gone. Here it is 0, here it is 0, so T bar. So C equal to T bar. Now further we will look into the next one. The next one is we are trying to put for value for D. So if you look at the D, so it is don't care, don't care, don't care, don't care, don't care, don't care, which is the last 6 don't cares. Then it is 1 for 0.